All right. Good afternoon. How's everybody doing? Enjoying TechEd so far? Learning things, important things? Great. All right, so I'm Michael Washam. I'm a principal cloud architect with Aditi, consulting company based out of the US. Formerly as a program manager at Microsoft, working on the Windows Azure Runtime team, where I worked on cloud services and PowerShell SDK. Prior to that, I was in evangelism, and I've done all kinds of fun, entertaining, powerful, interesting things with SharePoint on infrastructure as service. So how many of you have deployed SharePoint on Windows Azure? All right, 3 people. Was it really simple or was it kind of hard? Hard? Okay, so everyone thinks it's really easy. So it kind of is. So I'm going to take you through some of the details of how you can deploy SharePoint Server inside of Windows Azure infrastructure as service. So just to get started, the topic is obviously SharePoint on Windows Azure. One of the interesting things about Windows Azure is to launch infrastructure as service, which was literally just released earlier this month into general availability. SharePoint was part of the exit criteria to make IaaS launch. So the SharePoint team had to sign off that it was a good thing you could deploy SharePoint farms, you could successfully run a large-scale farm in infrastructure as service before the Windows Azure team would actually sign off on infrastructure as service. And the whole goal, of course, is to make sure that if you're running SharePoint on-prem, or that you can move it up into the Microsoft public cloud. So workload mobility is really critical. Microsoft wants you to be able to run, obviously, in Office 365. It's a great hosting environment. But if you need more control, more power, you need native code, you need to run internet sites, stuff like that, then you probably want to host it outside of Office 365. And this could obviously be your private data center, your private cloud, for instance, or you can obviously put it now in Windows Azure in the public cloud. So talk a little bit more about Windows Azure. Who has created virtual machines in Windows Azure to date? So some decent background in infrastructure as service. So let's go over IaaS a little bit more detail. So the IT pro experience, I know Microsoft calls everyone IT pros. I think a lot of people call themselves system administrators or whatever. But if you're an IT pro, system administrator, developer, you really have 3 key entry points for jumping into Windows Azure. Obviously, the Windows Azure Management Portal, which is what majority of people have seen. You'll see this in the keynotes. You'll see this in presentations. Secondary, everything you can do in the management portal, you can do from the command line. So there's Windows Azure PowerShell commandlets, and if you're running on Mac or Linux, there's command line tools that are written in Node.js that are cross-platform. They'll run on Windows, Linux, or Mac. And finally, if you're pretty hardcore and you want to take full control over the automation experience or whatever you really need to do, the same API that the Windows Azure Management Portal and the PowerShell commandlets use is exposed to you as well. And this is a service management API that everything uses in Windows Azure. From there, IaaS has support for key server apps. Obviously, SharePoint's one of them. Otherwise, this would be kind of a boring session. SharePoint 2010 and 2013 are fully supported. The reason SharePoint 2013 is bold and underlined is because there's an actual image in the platform image gallery where basically a sysprep version of SharePoint has already been created and it's ready for you to boot up. Now, I don't know if you've ever tried to boot this image up. It is a sysprepped image, meaning whenever you boot it up, it doesn't do anything yet. You still need to configure the farm. You still need to go deploy AD and SQL, et cetera. It's really meant as a component to building a bigger farm. So other key server apps, obviously SQL. Not going to get very far on a SharePoint deployment without SQL Server. SQL Server all the way from 2008 R2 up to current is supported. There's various other products, BizTalk, Dynamics, Forefront, et cetera. They're also supported in the Azure IaaS Cloud. I forgot to add the logo, but hope everyone heard earlier the week that Microsoft and Oracle announced a partnership where Oracle will be supporting their database in Azure. So that should have been a big red logo on this one. Okay, so let me just do a quick walkthrough of Windows Azure Virtual Machines for those of you who haven't seen it. And I'm going to also show you a little bit from the PowerShell side, too, if you haven't seen that either. So this is the Windows Azure Management Portal. If you're brand new to Windows Azure, this is to kind of orientate yourself. All the different resources you can create in Windows Azure, you'll see on the left. So websites, virtual machine, mobile services, et cetera, et cetera. They're all over on the left. And the creation experience is pretty similar for each. Whenever I go into new, I have different categories of cloud-based resources I can create. So compute, which is where we're going to be at with virtual machines, or data services for storage and SQL databases, not SQL Server, but Windows Azure SQL databases. So let's go ahead and create a virtual machine. And we'll pick from gallery. So here's where I can see all of the different various images that Microsoft provides at the platform level. So you can see we have Server 2012 Data Center and Server 2012 R2 Preview. This is a build that was literally just announced this week. Has all the cool stuff that they're talking about in IaaS across the hall. And here is your SharePoint 2013 trial image. This is the sysprep version of SharePoint. And this image is actually really critical if you want to try to provision a SharePoint farm. It saves you the time of having to download and install SharePoint and make your own custom image. So it's a huge time saver. So let's go ahead and pick the R2 Preview VM. So from here I can pick the instance size. So if you're pretty new to Windows Azure, you can see that you can go all the way down from extra small, which is you're sharing cores with other tenants on the machine, all the way up to a dedicated 8 cores with 56 gigs of memory. So I'll go ahead and pick 1 core, 1.75 gig, give it a username, and a password. And now I get to a little bit more interesting aspect of it. So whenever you're dealing with virtual machines in Windows Azure, there's a concept called a cloud service set. Hopefully everyone already knows about this. I'm just repeating things that are really boring. But it's kind of a strange concept, so if you're new to Windows Azure, it's something that you need to know. Basically, a cloud service is a public IP address. It's a public DNS name. So your dns.cloudapp.net, and all of your virtual machines can live behind this. So you can have multiple virtual machines all with a single public IP address, which makes it interesting for dealing with ports. So this acts as a container for all your virtual machines, especially in a SharePoint farm. They'll all most likely be in the same cloud service. So I can say this is going to be my cloud service. And it does have to be unique in a .cloudapp.net URL space. And then I'm going to pick a storage count. And you can think of a storage count as whenever you create a virtual machine, your VHDs actually are not stored on the disks in the data center. They're actually stored off in Windows Azure Storage. Windows Azure Storage is a separate service. And basically, you can pick which storage account you want to create these in. So I'm going to put mine in MW West US 1, which is going to go on the West Coast. Or I could put this in Northern Europe, which would probably be a lot faster considering my current location. And we'll talk about availability sets in a little bit more detail later, but just remember how you create one. An availability set basically allows me to create virtual machines at a data center highly available method. And I'll explain to you what that actually translates to. But just remember that to create an availability set, all I have to do is type in a name. And by default, Windows Azure or Windows Remote PowerShell is enabled. So whenever this machine boots up, I can actually drop to the command line and automate it remotely. At this point, I'm going to spin up a virtual machine. 3 to 6 minutes later, I should be able to log in and do something useful with it. So that's great. I'm sure everyone has probably seen that once or twice. But whenever you're talking SharePoint, and especially whenever you're talking dev and test environments where you want to quickly spin up a farm, test a web part, test some workflow, delete the whole farm, and do something again later, you're probably not going to do it through the portal. I mean, if you are, it's going to take you a really long time to walk through and do this. So what I want to show you today is how many of you have seen the Windows Azure PowerShell commandlets? Okay, so the Windows Azure PowerShell commandlets command line tool that allows you to do everything you can do in the portal, except you can do it in a much more automated fashion. So I'm going to walk through the same experience of creating this virtual machine, except we'll show it from the PowerShell command line. And this will make more sense to you later when I show you how to deploy a SharePoint farm from PowerShell. So from the PowerShell command line, I can create a new Azure VM config object, which has my name, which is my VM1, the instance size, just exactly what you saw in the portal, small, and it wants the image name. So we picked the R2 preview image before out of the portal. We had a nice little drop down. Here you don't have a drop down, so what you need to do to get that image name is call another PowerShell commandlet, Get Azure location. Get Azure location will turn back all the current data centers that are available for your subscription. Oh, I'm sorry. I contrasted images and location. We do need location too, so before I get too far ahead of myself, I'll keep track of North Europe, because we will need that later, but not yet. On image, so instead of get Azure location, I'll run get Azure VM image, and I'll select out the image name. And this is going to give us a list of all the available images that you can create from the PowerShell command line that you would also see in a portal. In some cases, you'll actually see more. So RightScale stores their images in the platform image gallery, but they don't have them in the portal. Not that you'd want to do that, but you could. So here you can scroll down and see the R2 preview image, just like what we saw in a portal. So I'll take the name of that image, store it in a variable. And now I can pass that as the image. And since I'm provisioning off of a image and not a disk, I need to tell Windows how to provision it. So there's a couple of different parameter sets I can use. I can do -Windows or I can do -Windows domain. If you're deploying a VM into a SharePoint environment, it's obviously going to be joined to Active Directory. So you'd want to specify the parameters to actually join to your AD domain. You'd want to specify your domain name, your admin account that has rights to AD, et cetera. And PowerShell will actually take care of registering your machine in Active Directory for you. So this one's just a real quick demo. I'm not going to do that. So I'm going to specify my username and password. And finally, I'm going to actually, I did need to set one more thing. So remember, we set the availability set name in the portal, and we can do the exact same thing from PowerShell. So I can say my AV set. And now, if I want two of these virtual machines, all I really have to do is copy and paste some code. So I can say my VM1 is now my VM2. Now I have two virtual machines. So it's a little faster to do this than what you did in the portal. But now in the portal, once a virtual machine is created, I want to go back and I add a data disk. So I have a separate step. So how would I accomplish the same thing from a scripted environment? So for each of these configurations, I can actually add all of the configuration I need to these virtual machines. So I can add a disk, a 500 gigabyte disk. So now each disk, or each virtual machine, when it boots up, will also have a 500 gig data disk attached to it. Got a typo somewhere. Someone needs to be louder. What? Top of the name? I still can't hear you. Here. I'll try to fix it with copy and paste since I can't hear. There we go. See, copy and paste saves everything. Okay, so now I have two virtual machine configuration objects, and all I have to do to create these is drop down and pass them to the new Azure VM commandlet, tell it my cloud service name, the location I want to create it in, and actually pass in the VM configurations. Oops. And this is how I could compose a deployment that I could later use to deploy IaaS or SQL or AD or whatever. And at this point, I hit F5, and a few minutes later, I'll have a couple of virtual machines up and running. Okay, so that's kind of the gist of how you create virtual machines. You can create them from the portal, PowerShell. I have REST APIs if you really want to dig deeper, but we could show how to do either of those. So let's talk about storage manageability and mobility. So storage manageability really is a concept that what's really critical and powerful about Windows Azure is you can take your virtual hard disks that you are spinning up your SharePoint VMs, and if you have them running locally on your laptop for your developer machine, you can actually upload them directly to your storage account and run them in the cloud. So I can take a VHD that I have running locally, upload it using command line tools, boot off of it directly, just like a hypervisor up in the cloud, and it's there. And vice versa, if I create a virtual machine in the cloud and I want to take it back on-prem and actually run it locally, I can do the same thing. Windows Azure has full support for image mobility, so I can move my disks back and forth. And then secondarily, if you are running, since we're not storing the VHDs locally on the file system, we actually store these off in Windows Azure Storage, you gain a lot of really highly available features without even trying. So one of the things that you'll see on the little animation, the little graphic on the left where you have the 3 highlighted drives, what that actually means is whenever you have a VHD stored in Windows Azure Storage, that VHD is actually copied 3 places in that storage account. So there's 3 copies of your VHD floating around. So if Windows Azure loses 1 copy, there's still 2 of them ready for hot failover. And even to go beyond that, Windows Azure storage accounts can be geo-replicated. So if you have a storage account in a data center and the entire data center goes down, the 3 copies of your VHDs can be replicated to another data center. So if Windows Azure decides that data center has completely failed, your data is still there. So not only do you have 3 copies in one data center location, but you can actually have it geo-replicated into another. And high availability features. This is what I want to talk about with availability sets. So availability sets give you a really critical piece of power, and literally all you had to do was group your VMs by names. So this is a picture, obviously, of a rack in a data center, and has some nice arrows to highlight that these blades are, in fact, physical machines. This is what your virtual machines run on in the data center. One thing to point out is there's a power unit rack switch. This is a single point of failure for the entire rack. And on top of that rack, there's also a switch that handles all the network traffic to all the machines in that rack. So you have 2 single points of failure in the rack. So what would happen to your application if your entire SharePoint farm was in this rack, right? Even if you have 2 web servers, 2 SQL servers, et cetera, et cetera, et cetera, you lose a rack switch, your entire farm is dead. So how you can get around that is by using availability sets. Availability sets basically allow you to take virtual machines of a similar type, so 2 SharePoint web front ends, 2 app servers, 2 SQL servers, or multiple, doesn't just mean to be 2. And whenever you group them in an availability set, Windows Azure will automatically split those workloads across multiple racks in a data center. So literally by just you telling Windows Azure that these 2 virtual machines or n number of virtual machines go together, the Fabric controller automatically handles data center high availability. So take that along with the load balancer, which distributes traffic across your virtual machines. If we lose an entire rack, Windows Azure will automatically take your virtual machine from that rack, move it over to another rack, reroute your network traffic, all without you lifting a finger. The only thing you did, period, was tell these Windows Azure that these virtual machines go into the same availability set. And of course, this is how you can get a 99.95% SLA, by following some simple guidelines on how to deploy your VMs. So there's another session, MDC B371, I believe it's on Thursday, maybe tomorrow, or it might be Friday, that goes into talking about building resilient applications in the cloud, and it goes a lot more detail about geo-replication. So if you're really into fault tolerance and you want to learn more about it, definitely hit that session up. So let's talk about highly available virtual machines. So I'm going to cover, first off, let me flip over to a pair of web servers I have. This is just two front-end web servers. We're not talking SharePoint yet. We're just showing concepts that will translate to SharePoint when we get to them. So what we have here is I have ISWFE 0 and ISWFE 1. So this is 1 and this is 0. So nothing remarkable about these web servers. If I go to endpoints and I click web, over on the right, you can see that load balance says yes. So my 2 web servers are set to load balanced. And then if I go to configure, you can see in the availability set that I have both of these web servers set up in an availability set. And one thing I did forget to mention on the availability sets that's really important is, so all your virtual machines are running on the same hypervisor that Windows Server 2012 runs on, or that you run with Hyper-V. So what that implies is Windows Azure does have to go back and patch their hypervisor machines. The host OSs that actually run your virtual machines get patched. And what that also implies to you is that they're going to go back and reboot your virtual machines every now and then. So in addition to the availability set keeping your VMs on different racks in data center for HA, it also tells the Windows Azure Fabric controller not to reboot both your machines at the same time whenever they do host OS updates. If you do not do the availability set whenever they go and do a host OS update, they could literally take your entire server farm down because they didn't know how to split it up and how it was architected. So this is just a really quick example of how two web servers can be configured in availability set and load balanced. And one thing I want to call out in this is there's an additional piece of logic here that you can take advantage of whenever you deploy a virtual machine from PowerShell. And the load balancer actually has health probes built into it. So there's two different types of health probes. There's a TCP probe, which basically, if you configure an endpoint with a probe, it will do a TCP socket connect on that probe, and if it gets an acknowledgement back, then the load balancer keeps that node in the rotation. And this is to basically make so if you reboot one of the machines in your load balance endpoint set, that it doesn't keep getting traffic even though it's not responding. That's okay. I mean, that's not a terrible solution, but if you're dealing with web servers, you can actually get much more articulate. You can actually point it to a specific web page that you can add logic into to get a specific status of your application. So let me show you, oops, wrong machine. Let me show you what that looks like. So I'm going to call get Azure VM. It's a PowerShell commandlet that basically pulls back all the configuration for a virtual machine. And this is the cloud service that my two web servers are pulled in. And I'm going to take that configuration and I'm going to dump it out to get Azure endpoint and show you the configuration of what we're currently running with. Okay, so if I go down, you can see the load balance endpoint here, which is called LB Web. This is all the properties of my load balanced endpoint set that I have on those two web servers. Pretty much what you'd expect. Local port is 80, the public port is 80, the VIP, this is a public IP address of the cloud service. But then we have these probe settings that are a little bit more interesting. The first one is /home/health check. And what this is a specific URL in my web application that if I don't actually have it there, the load balancer will not respond. It says this app is not healthy because whatever I specified there doesn't exist. Now, whenever you translate this to SharePoint, you do have to have a little bit more consideration because SharePoint doesn't, SharePoint's not like all the other applications out there. It has to do things differently. The first thing you realize is this only works whenever an application page returns back an HTTP 200. Everything's good. Right? So if I return back OK, then the load balancer thinks my app is good. If I return back a 500, it says the app is bad because it's crashing and doesn't know why, so it takes the node out. Well, SharePoint, by default, if you configure it, it's not going to return back 500. It's going to return back 401 because by default, everything is authenticated in SharePoint. 401 to the load balancer is as good as 500. It doesn't know what to do with it, so it's going to kick your SharePoint nodes out. So again, this is a piece of functionality that you should absolutely take advantage of for high availability of SharePoint, but you do have to take into account that the load balancer cannot pass credentials in to your health check page. So you have to create an anonymous / something that SharePoint can respond to tell the load balancer that it's in good shape. And just a real quick example of how this works. This is how you too can troubleshoot your application whenever you try to deploy it with SharePoint. So quick example. So the web server has a little bit of code in it that basically tells you which server it's running off of. So this one's running off ISWF1. If I hit F5 a few times, you'll see that it's also running off of 0. So this is a true, it has load balancing turned on. Now, I can modify my health check page to kick this server out. So if I take this, one of the server names, ISWF1, out of here, my health check code actually checks to see if the server is in that config, and if it's not, throw a 500 error. So I can make this code change, and I can publish it out to my VM. And I'm using web deploy for content synchronization. So this is going to update my application, and now once all the content is synchronized, it's going to ISWFE1 is going to start throwing a 500 error. So once it's all synchronized, it should no longer be in the load balancer. So this is something that you will need to know whenever you set up SharePoint and IaaS, is how to troubleshoot this. And the easiest way to figure out what the load balancer is doing is to look in your web logs. So I'm going to log into ISWFE1 and see if I can see my 500 error popping up yet. This is how I originally figured out what was going on with this when I had deployed SharePoint and nothing would work. Is you go open the logs and you see lots and lots of 401s. So here are my web logs. You can see there will be most of the traffic is going to be from the load balancer. So load balancer agent, and then this number right here is the HTTP status code. So you can see that it's been getting a 200 for a long time. It's all happy. Everyone's good. But if I scroll down to the bottom, you can see one of the last requests is now my code is throwing a 500 error. So the load balancer knows that this is not a happy node anymore. And if I go back to the load balancer and hit F5 a few times, I should only see 0. I shouldn't see 1. So pretty straightforward feature, but it is something to be concerned about, and knowing how the authentication works to take advantage of it. Okay. I think I lost my place here. Okay, there we go. Okay, so let's talk a little bit about hybrid networking. How many of you have set up a site-to-site network using a VPN device? Okay, how many of you would really like to or need to? All right, so what I'm going to talk about are the capabilities. So Windows Azure Virtual Networks has a concept called a site-to-site network. And what this allows you to do is, using a VPN device on your on-premises data center, you can establish a secure VPN tunnel to the Windows Azure cloud. And used to, whenever IaaS first launched, this was only with Cisco and Juniper physical VPN devices. Something that they did with GA is you can now use a Windows RS server, software VPN, to set up your tunnel, which makes it much more convenient for the vast majority of people setting this up. So this is what, in the SharePoint world, can give you true hybrid connectivity. So I can have AD deployed on-prem, and I could put a domain controller up in the cloud that replicates from my on-prem, and I can literally extend my domain controller out into the cloud and have a full SharePoint farm running in the Windows Azure data center using my corporate AD. And this is just a quick slide if you have previously used virtual networking, Windows Azure Virtual Networking, to know that we do have much more options now. So Juniper Networks, F5, Citrix, WatchGuard, Windows Server, finally. These are all now fully supported for VPN site-to-site capabilities. Another capability in the networking space that's been added in the past few weeks is point-to-site. So the difference between site-to-site and point-to-site. Site-to-site allows you to segment off whole subnets and whole networks on your corporate domain, your corporate network, to talk to the cloud. Point-to-site allows you to segment a machine, like your laptop, to be on the same virtual network as the cloud. And the benefit here is, you're a developer, you're a SharePoint developer, you can set up a VPN tunnel from your laptop or from your desktop, your dev machine, where you're on the same physical network as your SharePoint SQL servers and AD servers are. So you don't have to go through public endpoints. You literally set up the tunnel and you're on the same network. And this is a new option. And basically, it's pretty easy to set up. You can basically download a few certs, configure your VNet, and you're on the same network. Now, to know more about this, there is another networking session that's going to go into detail and actually walk through configuring point-to-site. Should definitely check those two out. And finally, how many of you are using Web and Worker Role? Anyone? One? Is anyone? Okay, so Web and Worker Role are the Windows Azure Cloud Services, the Windows Azure PaaS service. You can, one of the things that a lot of people aren't fully aware of is you can take a PaaS application and actually put it on the same virtual network as an IaaS application. So I can create a virtual machine and put it on the same VNet as my Web and Worker Role. Another couple of options that are brand new, that are really powerful, are pay by the minute, VM stop, payment stops, and MSD and agility. We cover those a little bit. Previously, before the beginning of the month, Windows Azure, like a lot of other cloud vendors, whenever you used a virtual machine, there was a lot of rounding going on. So whenever you would use 45 minutes, you may be paying for an hour of usage. A billing change was made recently that basically where you are only paying for what you use down to the minute. So there's no rounding. So literally, if you use a machine for 45 minutes and shut it off, you only get charged for 45 minutes. And the really nice thing is if you accidentally spin up an A6 or an A7 virtual machine and you're like, oh, I didn't want to, you can actually delete it within the first 5 minutes and you don't even get charged for it. So it's really easy to take advantage of the whole pay for your usage. And this may not seem like a big deal to most people because it seems obvious that you shouldn't do this. But previously in Windows Azure Infrastructure Service, whenever you started a virtual machine and you stopped it, you would still get billed for it. I know everyone's like, well, that's a bug, right? It's not a feature. Well, yes, it is a feature now. So today's Windows Azure Infrastructure Service, whenever you actually stop your virtual machine, you just hit right-click and hit stop. Your virtual machine configuration stays there, but you actually don't get billed for it anymore. So that is a true feature, and it's something that has literally just popped up in the past few weeks. And finally, I'll talk a little bit about MSDN usage. How many of you have MSDN subscriptions? All right, how many of you have your Azure subscriptions activated? Awesome. Okay, so if you don't know, if you don't have it activated, you should know that there's been some significant improvements on the Windows Azure and MSDN story. So previously, you couldn't even use MSDN products that you had a license for in the public cloud. The licensing was so goofed up that you literally you couldn't take your SharePoint, dev licenses and run them in the cloud officially. That has been changed, so now anything you have in MSDN can actually run in Windows Azure. There also used to be a big, long plan of all the different gadgets and things that you could run run with your MSDN subscription, and that's pretty much been wiped out, and they just gave you a flat dollar amount. So if you have a premium subscription, you get $100 a month of free or of Azure subscription, and the rates have dropped dramatically too. So for Windows Server, SQL, BizTalk, et cetera, they're all basically a flat 6 cents an hour for compute. So on MSDN subscription. So this makes it really cheap to basically spin up and do your SharePoint dev test up in the cloud. Okay, so let's rewind a little bit and talk about the last SharePoint conference. Did anyone go to the last SharePoint conference in Vegas? I think it's where it was. So interestingly enough, the last SharePoint conference was huge. There was I don't remember how many, it was 7,000 or 8,000 people there. All the hands-on labs for doing all the SharePoint dev work were all running in Windows Azure. And this is whenever Windows Azure IaaS GA, whenever it was still in preview state. And they actually ended up spinning up 1,800 SharePoint virtual machines on Windows Azure. So it took 2 data centers. It took 14 subscriptions, spun up 1,800 VMs, and there was 13 terabytes of memory in use, along with 14,400 cores. But the whole point was, really, can Windows Azure do that, right? And they worked directly with the product team and made sure everything worked. But it's kind of a proof point that you can take SharePoint on Windows Azure and make it scale out dramatically. So now, obviously, that's not a real-world implementation. You don't just use SharePoint on one VM and do hands-on labs all the time. Can you do a real-world deployment? So part of the SharePoint product team and support and consulting org at Microsoft has been working on this documentation called the SharePoint product line architecture. There's actually a product line architecture for Link and Exchange and a couple other products too. But what this is it's basically prescribed guidance on how to deploy SharePoint, how to make it scalable, and they have scenarios that you should do to make sure that you did it right. The Azure Center of Excellence, which is a team back at Microsoft and Consulting, actually went through this PLA and deployed it in Windows Azure because the entire documentation is written assuming it's going to be on-prem. So they went through this PLA, this prescriptive guidance, to find out what the differences are, what the deltas were between deploying it in the cloud. What they found out was basically there's not a whole lot of difference at all. There's a little bit of upfront implementation differences, like where do you store your disks, how do you set up your networking. But from a SharePoint perspective, it's all pretty much the same. Your biggest concern is IOPS, and you need to know how to structure your data. They did use Visual Studio Team System Test to actually test this out, a small farm, and I'll show you the architecture of that in a bit. And what they ended up with is they could get 300,000 users at 250 requests a second, and accessing 400,000 unique documents in a 220 gig content database. That's for a test case, that's pretty impressive results. So some of the architecture tips they walked away with is I mean, I don't think this is a surprise to anyone. For SharePoint, IOPS are really important. This is whether you're on-prem or whether you're in the cloud or whether you're running Office 365. Not you, but the people that run Office 365. Make sure that you're building out your data disk correctly. Put TempDB on multiple data disks if you have to. So in Windows Azure, just like Windows Azure data disk, you can think of them just like a physical disk on a virtual machine. There's so many IOPS per disk controller, and there's so many IOPS per data disk in Windows Azure. As a matter of fact, there's guaranteed pretty much up to 500 IOPS per disk. So do the math, and you can figure out how to kind of calculate how many disks you should have. Split the content database into multiple files. So using SQL file groups. SQL file groups can split basically a SQL database file across as many disks as you want it to. Put the log files on a separate disk to reduce contention. Format data disk with read caching, and you can set that through the portal or PowerShell in 64K blocks. And make sure that you don't really put anything else on the C drive. There shouldn't be anything contending for the OS disk other than SharePoint and the OS itself. Scale out, not up. So you saw the instance sizes in Windows Azure. Currently, the biggest I can get is 8 cores and 56 gigs of RAM. Therefore, you should probably consider your architecture to be a scale-out architecture. In SharePoint being the pluggable architecture that it is, means you can have as many SQL servers as you want. For every content database, you can add a SQL server if you wanted to. Not saying you should, but you could. So you're heavily trafficked. Make sure that you're architect out and make sure your farm can scale if needed. This is the small farm architecture that was described in the PLA that they tested. So you can see that basically you had 3 web front ends, 2 app servers, 2 SQL servers, 2 AD, and they were testing over hybrid connectivity. So I'm going to talk a little bit more about this architecture in detail. So just to kind of break it down into the web front end piece, they had the distributed cache service, the front end services, workflow manager, query processing, and index replica. And you can see the disk structure that they used. Basically, the OS disk was 127 gigs. They put the page file and the SharePoint blob cache on the D drive. So in Windows Azure, the D drive is special. It's not stored. That's the only disk that's actually not stored in Windows Azure storage. The D drive actually points to the physical disk on the machine in the rack, which also means that if you put something on the D drive, you better not need it later, because there's a really good chance that if something went wrong with that rack, your machine's going to be your VM data is going to be put on a different rack, and all that data you had on the D drive is gone. So the D drive, rightly so, is only for temporary data. So page file and SharePoint blob cache, perfect candidates for that. They split the index log and the index on separate disks. So 40 gigs on the E drive and 500 gigs on the F drive. And one thing I also want to call out on Windows Azure Storage is the 40 gig, 500 gig, each of those data disks can actually go up to a terabyte. So each data disk in Windows Azure can be a terabyte. So, you may wonder, why did they create 40 gig disk? That's a good question, right? Because the answer is you don't get charged for that 1 terabyte disk when you create it. If you have a 1 terabyte disk and you have 40 gigs written into it, you're only charged for the 40 gigs that are actually written, not the remainder gigabytes that are empty. So that's another nice thing about Windows Azure, is you can plan for massive storage and not have to pay for it until you use it. The app server tier, they were running analytics, backend services, crawl, admin, content processing, similar disk configuration. And finally, the data server tier, which is the most interesting from the disk configuration, is to accommodate a 220 gig content database. They had to split the content databases up across multiple data disks because you get really good write performance if you can spread that out, and they took advantage of SQL file groups to have these data files distributed. So Windows Azure and SharePoint. I'm going to call out the pieces that are a little different. And they're not a lot different, but a little bit different. So the very first thing you need to do if you're deploying SharePoint is don't go create a VM. Every person I've ever worked with in Windows Azure that wants to go create SharePoint, they jump in the portal, they go create a VM, they install AD, then they go see everything like you do on-prem, and it'll work for a while. The problem is if you create a virtual machine outside of a virtual network, the IP addresses you get assigned are not guaranteed to stay that way. So, a week later, your domain controller has a new IP address and none of your machines can connect to it and your whole farm is toast. So, step number one, deploy a virtual network. It doesn't have to be a complicated virtual network. It doesn't have to have a VPN device. It just has to have a virtual network in the cloud. And the biggest reason is the IP addresses of your machines will have an infinite DHCP lease. It's still not static, and under no circumstances change your NIC driver to make it static, because in your machine you can't connect to it at all. It's still going to be DHCP, and whenever you install AD, it'll say, hey, are you sure? Are you crazy? You're installing on a DHCP server. Yes, you are crazy, and tell the wizard you said so. So deploy the VNet first, and you'll get basically a DHCP lease that lasts 140 years, I think is the number. So if your SharePoint farm is going to be around longer than 140 years, this may not be the right solution for you, but assuming that's a reasonable timetable, that's your first step. Second step is make sure that you take advantage of data disks. As I said, you don't get charged for the data disks unless you actually have data on them. So make sure that you're spreading your I/O across, because you'll get much, much, much better throughput. And whenever you're deploying SharePoint, think tiers: web tier, app tier, data tier, etc., and group each of those tiers into availability sets. Remember, it's just a label. You put a label on and you get all this magic high availability that Windows Azure does, and all you did was come up with a unique label. I mean, not even a unique, a label for all your VMs in the tier. It's not that hard. And finally, this is the only part that I will say is kind of a pain, is use HTTP health probes on web front ends. This is a part where you do have to go configure an anonymous endpoint that the load balancer can point to. And secondarily, you can't set a probe in the portal. You can only set it in PowerShell. So this is something you don't have to do, but if you really want a fully available or highly available farm, you should definitely look into. And finally, I'm really lazy. Whenever I was in evangelism and I'd have to create a SharePoint farm, to figure out how to do it for demos and stuff, it took a long time to walk through. So as we built these things out, we start learning how to automate it. Creating a SQL Always On cluster, creating AD, creating SharePoint farms, blah, 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 blah. It's a lot of work. And if you do it all the time, like if you're deploying a dev and test farm, you want to deploy an entire farm, test your app out, and you're done, and then you're going to do that again next week. Do you really want to spend the first 2 days of every week configuring SharePoint? Automate. So it's really important. And the second bullet is just nice. Whenever you spin up 10 VMs in the cloud and you want to test it, 10 VMs is probably pretty expensive if you do the pricing calculator and leave it up for an entire month. But if you spin up 10 VMs for 15 minutes and shut them down when you're through, and you can do that all in a single line of code from PowerShell, it's probably pretty cheap. And I'll show you a quick demo on how to do that at the end. Okay, so let's talk about a highly available SharePoint farm. So I'm going to go back to the Windows Azure Management Portal. And under Virtual Machines, you can see that, actually, I wish I had, let me zoom it on here real quick. There we go. You can see that I have quite a few servers here. So I have 2 SharePoint app servers, 2 SharePoint web servers, and 3 SQL servers. So how this is configured is the 2 web servers are load balanced. The 2 app servers are just basically waiting for requests from the web server. And one of the app servers is the central admin site. And the SQL servers are actually in SQL Always On availability group, where I can fail over from SQL 1 to SQL 2. And they're in mirroring mode, so theoretically they should have automatic failover. You can also, previously, up until GA, you couldn't actually use SQL Always On with an active listener, but some new functionality they've added in endpoints should make that happen. I haven't actually tried it yet, but it should be possible to do. So if I wanted to make this farm highly available, each of these would be grouped into a separate availability set. So app 1 would be an availability set, web 1 would be an availability set, and so would SQL. So if we walk through the topology, click on app 1, configure, they're both in the same availability set. Same thing for web 1, and same thing for SQL. Oh, and I forgot, sorry. you have identity, so we have two separate Active Directory servers as well. So we have two domain controllers up in the cloud, both in an availability set. So this one SharePoint farm for full HA takes 9 servers to do it because we have to have redundancy at every level. Just want to show the configuration I used for the health check. So I'm going to use PowerShell to pull back the endpoint settings. If you look, got a lot of endpoints here. How I did the probe on this one's a little different. And this may not be the best way, but it certainly is an option. What I've done is actually, for all intents and purposes, I really just pointed at a different website. It's listing on port 8080 for IaaS. And basically it goes, I turned on the default website on port 8080, so whenever it pings it, it's always going to get an HTTP OK. Now a real solution would have a page there that actually validates your SharePoint site is working. It could check, make sure that it can get to a document library, or it can query your search index. It could do all these things that would actually validate that your users are getting the behavior that you expect them to, and then would return back OK. Now, if one other low-level implementation detail is I'm going to show you the actual update domain and the fault domain. So if you're real curious about how this works, Mark Arsenovich is having a Windows Azure Internals talk a little bit later today. Go to it, and after you see the fault domain and the upgrade domain, it'll actually make sense for what he's telling you. So each of these are grouped into an availability set. So if I look at each of these virtual machines, so SQL 2 here, you can see that the fault domain is set to 1 and the upgrade domain is 1. Now if I go to SQL 1, which I believe will be right here, you can see that the fault domain is 0 and the upgrade domain is 2. What this means is fault domain puts them in different racks. So fault domain 0 is in rack 1 and fault domain 1 is in another rack. And the upgrade domains basically say that whenever Windows Azure Fabric Controller goes to update them, they're going to do each individual upgrade at a time. So if you ever have two virtual machines that are serving the same purpose, and they're both in upgrade domain 0 and both in fault domain 0, you did it wrong and you need to go change your availability set. And the availability set is what configures that. You don't set those two settings directly. Oh, and of course I forgot to show you the farm. So lo and behold, this is a SharePoint farm. So it's nothing. I didn't do any kind of fancy customization. There's no demo or anything like that. It is just a SharePoint farm in Windows Azure, and you can see the URL. So cloudapp.net, that tells you you're running in a Windows Azure URL. Now let's talk about how I created that farm. If I was going to create that the old-fashioned way, I'd have to, like I said, create my VNet. I'd have to then create an AD server. And once AD was booted up, I have to run DC promo, install AD, configure my domain controller. Then I have to install another virtual machine, join it to the domain, install another DC promo. From there, I have to install SQL Server, domain join it, create a cluster, et cetera, et cetera, et cetera. It's a week and a half to a 2-week operation. It just is. There's no getting around it because it just takes a long time to do all those operations. So from an automation perspective, we got really tired of having to do this every time TechEd came around. So we put together a set of PowerShell scripts that can basically do all this for you. So before I show you the cool scripts, I'm going to try to drill into you the tenets of why this is important. How many have heard the DevOps buzzword flown around? Okay, so DevOps is more, they talk about it more in the Unix and Linux crowd, but what it really consists of, instead of IT pros and system administrators and developers going through and manually configuring things every time, it means that they're getting together with the developer staff or whoever owns the application and figuring out how to automate the deployment and configuration of their application. So what it really means is you're going to probably write some code to get something deployed. It doesn't mean you're going to write an application. It means you're probably going to write some script to automate some steps. There's tons of benefits, obviously. The shorter development cycles, reduced costs, perfect example is this SharePoint farm. It took me about 18 seconds to actually create that SharePoint farm, literally. It took my laptop 5 hours because it was spinning up, making it all do the work, but I didn't care what my laptop was doing. I was in there watching TV while it did all the work. So just to kind of beat this dead horse a little bit is I want to compare and contrast an automated deployment with a traditional deployment. Hopefully everything isn't this bad for real, but if you were to deploy SharePoint, brand new data center, the very first thing you're going to have to do is set up your network infrastructure. This could mean wiring cables, installing switches, getting dirty, sweaty, all kinds of hard work. From there, you're going to have to set up your server infrastructure, which likely means you're going to have to go order a bunch of servers. You're going to have to call your favorite OEM and have them ship you the servers. You're going to have to open up the boxes, get paper cuts and tape all over your fingers, and actually set up all these guys, get all the right firmware updates and network drivers and the SCSI RAID controller drivers. From there, you have to install Windows. You have to patch it. And once you're done, that's when you actually go install AD, SharePoint, and SQL. So your 2-week process, week and a half to 2 weeks in the cloud is 3 to 4 weeks starting from scratch. Now, if your boss wants to be agile and said, hey, we have 6 different teams do SharePoint dev work and they each want their farm and they want it by Thursday, I don't know how you're going to pull that off, right? That's a lot of work. So now we look at the cloud. The cloud solves all the problems. Windows Azure is just perfect. Life's good. So at least now you don't have to actually run cable. You just configure it all through a GUI. You pull up the Windows Azure Management Portal, you create your network, then you create the virtual machine through the portal or through PowerShell with the OS. You still have to patch it. You haven't got away from that. You can, of course, get software to manage that for you. Then you install and configure the app. So, the cloud definitely improved things, right? I'm not managing a bunch of network cables and switches and routers. Someone else is doing that for me in their data center. But I still have a lot of work to do. So even in a cloud environment, if I have to do this for the entire 5 or 6 departments that all need a SharePoint app, it's still going to take me a lot of work. Not as long, which just means they're going to make you work harder. So if you look at doing a cloud deployment and automation, the first step is not to create a virtual network. The first step is, how do I make my life automatable? What do I have to do all the time, over and over and over, that is really slowing things down? And this is where you basically sit down and you do an inventory of the things that you're doing on a repeatable basis. From there, you figure out what you're doing all the time, and you create a configuration automation or configurable automation. That sounds really vague, but all that really means is you've got to figure out how to script whatever you identified that's repeatable. You're going to spend a couple of days or weeks even writing scripts. For example, to do the SharePoint scripts we built, it took about 2 months, a month and a half to 2 months, and that was a lot of work to write a full-blown SharePoint in the cloud automation deployment script. But now, whenever I'm ready to execute a SharePoint farm, I run my script and bam, I have a SharePoint farm. There's no magic to it. There's no tweaking. There's nothing else I need to do. I just change the parameter and hit F5, and it just kind of happens. Of course, there's always going to be non-repeatable tasks. Something you have to do, copy over Team X's app. They just got it brand new. You can't have automated it because you've never even seen it before. So now if I have multiple environments, I literally change a variable, hit execute again, and I have my repeatable deployment. So what kind of tasks are good for automation? Again, tasks that are repetitive. In most corporate environments, when I was in consulting before, spinning up web farms for dev and test was a really big deal. It took a lot of work, but it was something that people had to flatten the boxes and reconfigure everything all the time. So just deploying a web server, for instance, just to deploy an app is probably something that's worth scripting. Tests that are really complex, like test AD environment or test SQL Server or SharePoint. What we're talking about today, really good examples. Tests that can save you money. In the cloud, when you're not using those VMs, you can script shutting them all off. Good example is your dev test team, they're all out of the office by 5:30. Write a scheduled task that toasts all the VMs in your subscription at 5:45. So now from 5:45 till the next morning, all your VMs are off. You're not paying for it. And you can kick them all back on before everyone gets back to work. All automated, and you just saved your company from paying for 70% of their usage for the day. And of course, domain expertise is another good example of what's really good for automation. say, for example, you hire a security auditing firm to come in and they review your servers and tell you exactly what you need to do to lock them down, and they give you a big white paper to review, and then they leave. And then you go back through the white paper, and part of it makes sense, but part of it doesn't. So wouldn't it have been just a lot easier if they'd just give you a script to run against your VM that told you, you're missing this? Much better example. Hard facts versus theoretical. So at the Windows Azure automation perspective, there's two really key pieces that you probably might care about, but maybe not. The Windows Azure Fabric Controller is the guts of the automation piece. Again, go to Mark Rusinovich's talk if you want to know details about how it works. But basically, it's a piece that spins up all the stuff in the data center, spins it up, gets rid of it, does all the magic behind the scenes that you don't have to do anymore when you're in cloud data centers. The Service Management API is what exposes all the functionality to us, the end users, to manipulate the Fabric Controller. We never talk to the Fabric Controller directly. We talk to the API. And for the most part, most people never talk to the API directly either. They'll talk to PowerShell or the management portal or the XPlat command line tools or various other services out there. System Center has a great orchestration piece that can talk to Azure. There's third-party tools out there like RightScale and Scale Extreme that can do all this magic as well, and they all do it through the Service Management API. So the set of PowerShell scripts that I've been talking about, basically they use remote PowerShell to do an automated deployment of Active Directory, SQL, and SharePoint. There's 2 sample configs that are available, so if you want to try this out, just go to github.com, and there's a zip button. You click the zip button, it'll give you a zip file that has all the PowerShell scripts. And I'm going to walk through creating a SharePoint farm here in a minute so you can see how it works. But the first template that you can create is a highly available template. This will spin up 9 servers, so just remember to shut them off when you're done. Otherwise, you're going to get a big bill, big surprise. It'll spin up 9 servers, each in their own availability set. So SharePoint web servers will be in an availability set, app, SQL, and the domain controllers. It will basically configure everything HA. So the web servers will be load balanced. The SQL servers will be in always-on availability mode. You can fill them over to your heart's content. And one thing to keep in mind is each of the tiers by default, so the web tiers are large, the app tiers are large, the data tiers are A6s. If you have a 20-core limit on your subscription, you're probably going to run out really quick. So either bump your subscription quota by contacting support, or you can go adjust the config files to have smaller instance sizes. A second template is probably the one that you'll want to try first, because it doesn't take 5 hours to execute, is a single virtual machines template. This basically spins up 1 VM per tier. So it'll spin up a web tier, app tier, a web/app, everything combined on SharePoint, a SQL server, and a DC. Oh, and the other thing, this actually creates all the virtual networking for you, so you don't have to. So let's walk through creating a SharePoint farm. So the first thing I'm going to do, so one thing I do want to point out before you run this is you need to, if you're running PowerShell ISE, Power GUI, PowerShell just a command line tool, you need to start it elevated. And the reason is each of these virtual machines, it enables with remote PowerShell, and the first thing it does is it establishes a self-signed certificate inside the VM for the remote PowerShell SSL connection, but it downloads and installs that cert on your local machine. And to do that, it has to have it run as admin rights. So start the PowerShell GUI in elevated mode, and from there you have to enable CredSSP on your machine, not the cloud machine, but your machine. And what CredSSP does is it allows you to delegate your domain credentials that you're running on your local machine, which you're actually not running on your domain machine, but you're passing domain credentials into PowerShell. You're passing it to a machine, and it then, in the cloud, uses those credentials to a double hop off to another machine. And because that's apparently a security thingamajig that you have to be aware of, you have to configure your client machine first before you run these scripts. And if you don't, about 3 hours in, you'll get 3 hours into your HA deployment, you'll get all these red errors in PowerShell, and you'll get really ticked off that you forgot to do that because you have to go delete everything and start over, and it takes another 5 hours before it's finished. So to do that, it's 2 steps, and you don't have to take notes. All of this stuff, the documentation is in the GitHub repo. There's a wiki that tells you how to do all this stuff. But if I were to do this, you need to run enable wsman credSSP, delegate computer, star.cloudapp.net. This basically delegates your cloud service to do credSSP, and I need to tell it the role, though, because this commandlet works for server implementations and client. So I'm going to tell it client. And it's going to prompt you, are you sure? You could pass credentials and someone in cloudapp.net could blah, 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 blah. And yes, you're sure. Okay, so now my client is not ready for credSSP. You would think that that would do everything I need to do to enable credSSP, but it's not. The next step you have to do is run gpedit.msc. This was super easy to figure out how to do this, by the way. Not really. So go under Administrative Templates, System, Credentials Delegation, and the next step you want to touch is allow delegating fresh credentials with NTLM only server authentication. I mean, that's obvious that that's what you needed to change. So you double click on that, tell it enabled, and you want to add wsman star.cloudapp.net. And thankfully, again, you don't have to memorize this. It's all in the wiki, because I'd be really impressed if you could memorize all this. I've only done it 100 times because I wrote the script, so I happen to have it memorized. So that's now your laptop is officially ready to run the PowerShell script. So now I can open up the scripts that I downloaded off of GitHub, and it's a really big, complicated script, but from what you use it for, you don't really have to do a whole lot with it. The only thing is you have to pick your template, whether you're going to do the highly available template or the single VMs template. You have to tell it the data center location you want to use. So I could do West US or I could do North Europe. I'll give that a shot. And pretty much ignore the script folder parameter unless you want to move your configuration file somewhere else. But there's a couple other things I can do. So I can specify, whenever it creates AD, I can tell it which domain controller or what domain to use. So the parameters here are documented. So I can say -domain, and I'll say TechEd.eu.com. I'm sure that's actually a real domain, so it won't work, but that's okay. Then I can say DNS domain. I'll just do that same thing. Sorry. All right. So this is pretty much all I need to do to spin up a SharePoint farm. There's a couple other settings I can do. If I can specify the administrator account and the admin password. So if I don't select them, the admin account will be spadmin, and the password will be really long and complicated because it's auto-generated. So if you don't want to have to type in a really long auto-generated password every time, you can specify one to use. You can specify the app pull account and the app pull password. What other nifty things you can do? You can actually just pass it -config only, and what it'll do is it'll generate the XML files needed to do this, and then you can go customize them further if you want. And before this runs, let me actually jump into the XML files real quick just to show you. So if I go under config, here's the 3 different configuration files I have. The first one is the virtual networking setup. If you're not doing anything interesting with VNet, like you don't want to connect it to on-prem, you can pretty much ignore that one. Everything should work just by default. The second 2 templates are the highly available and the single VMs. And I'll show you some of the settings that you can only do from a config file if you really are interested. So if I go into the config file, you can see there's going to be really 3 files. The -autogen ones are what is the end result after you run. It modifies the base config files and saves them with -autogen. But a couple of good examples of what you'd want to change here is instance size. So if I open this XML file up, you can see the domain controller, New Forest, replica. But if I scroll all the way over, you can see the instance size. So I put mine to small, just running out of instance sizes. but you can also see the subnet name and the VNet. So if you wanted to use your own custom VNet, you are going to have to go in here and modify the XML to point to that. That is going to be created for you. And the same thing for your SQL servers. So the SQL servers, these are just the blanks, but they'll actually be auto-populated whenever you actually run the script. So you can go in here and change your instance sizes. So quorum size is small, but the VM sizes I put as medium. Obviously, A6s are going to run much better because they have much more memory, but whenever you're running low on cores like me, you got to do what you got to do for testing. So let me go ahead and kick off this script. So I didn't specify a password, so it's going to generate it for me. I didn't specify a cloud service name, so it generated one for me too. And I didn't specify a storage count, so it's creating a new storage count in North Europe. So it's pretty much automatic. I don't have to go in and do anything in the portal first. It'll create everything on my behalf. If I don't want it to create resources, I can specify the existing ones on the command line now. So if I didn't want it to create a new storage count, I'd just specify the storage count to use as long as it's in the same data center as the location I specified. And probably, assuming I didn't typo anything in the parameters, about an hour to an hour and a half from now, there will be a live SharePoint farm with 3 servers in the TechEd EU domain. So this is kind of, from an automation perspective, this is how you can really spin these SharePoint farms up really quickly and try them out in Windows Azure. And of course, this is all in PowerShell script, so you can customize it, tweak it, do whatever you want to with it. Okay, and if you really want to learn more about PowerShell, I just did a session a couple hours ago, so you can see it recorded on online once they get it posted. All right, so I have one final demo I want to show. And this is what I wanted to show about dealing with Stop Azure Billing. So I can say get Azure VM. And you can see all the virtual machines that are running in my subscription. So the cloud, the VMs that we created earlier. And here's my 9-server SharePoint farm. So this is one of the SharePoint VMs that was spun up earlier from PowerShell. And now that I'm done with my session, I don't really need it up and running anymore, so I don't want to get billed for it. So what I can do is specify service name, and just pipe that out to Stop Azure VM. Oh, and I do want to do force. That way it doesn't prompt me. And it's going to enumerate through all 9 of the virtual machines, and it's going to shut them all down, so I'm no longer getting billed. And the beauty is, when I'm ready for this to be up and running again, I just go back and start the virtual machines up, and I have my 9-server farm again. There's no recreation or anything. It's just will all be there when I'm ready for it, and I didn't get charged in interim. The only thing you will get charged for is a VHD, the storage size. So each disk, data disk, you'll actually, that stays and is getting billed. You're just not getting billed for the compute time. But storage cost is significantly cheaper, so I consider that a worthy cause. All right, so questions? Sure. I can't hear. They're doing something right behind me. You want to come up afterwards? Okay, perfect. Any questions from someone? Closer? Okay. So some additional SharePoint resources, Visual Studio Test, et cetera, and please make sure you scan and eval the session, and I'll be up here for a few minutes if you guys have any questions you want to talk about Windows Azure or SharePoint. Come on up. Thank you very much.